Hello again. This is a lot of videos for this one section. Here we're going to do video 70, that's a 3, kind of ugly. And it goes something like this. Give all 6 trigonometric functions values for each angle theta. Rationalize the denominators where applicable. And the only information they gave us is tangent theta is equal to negative 15 over 8. And theta is in quadrant 2. Okay? Now I can do this exactly the same way I did problem number 65, but I'm actually going to use one of the Pythagorean identities. And if I look on page, what the heck page is that? On page 35, one of them says tangent squared theta plus 1 equals secant squared theta. Okay? And this will actually take care of my my Pythagorean theorem instead of having to draw everything out. Okay, so let's get on it. Tangent squared theta, that's negative 15 over 8 squared plus 1 equals secant squared theta. Okay, once I go ahead and do that, 15 squared is 225 over 64 plus, now instead of 1, I'm going to go 64 over 64 just to get the same denominator. And I'm going to get secant squared of theta equals 225 plus 64 is 289 over 64. Now this gets weird because I got to take the square root of both of them. And here, I'm going to write this a little reverse here. Secant of theta is equal to, what's the square root of 289? 17, right? Everybody knows that. So my answer is 17 over 8, or negative 17 over 8, right? That's like saying if you take the square root of 4, your answers are plus or minus 2. So that said, the question is, which one is it? Now, we got to go back up to the problem. Let me go with the marker. Theta's in quadrant 2. So in quadrant 2, our x is negative and y is positive. So the secant in quadrant 2 is going to be negative. And you can verify that with a table on page 31. Okay, so our proper answer is this one. Okay, now that's great for secant. We already have tangent. It's up here. Okay, now they wanted all 6, so you have to do all the partner functions. The partner of secant is cosine. So cosine theta is then going to be negative 8 over 17, right? It's just the reciprocal of secant. And then sine is going to be, we got to find the last leg of sine. Opposite over adjacent. We can figure that out using quadratic formula. I'm sorry, not the quadratic formula, but like Pythagorean theorem if we want. And that's it. I'll let you guys do the rest.